Morning, everybody. Hopefully, I think audio is working. Um, Morning, Vince. Might just be morning, Brooksy. So that was awesome, Vince. Vince went in and coded up the rest of this thing. So now we might just be comparing notes to see how I go about it. Morning, Dice K. So this is our last lab of the semester. We will have one more meeting on Tuesday next week. Well, we'll just sort of do I don't know if I'd call it a quick review, but I can't imagine we're going to go over more than an hour. So anyway, final lab will be completed today, and we will then meet one more time on Tuesday next week. And there's a short review assignment. Just to close out the semester. So now we are finally almost getting there. Good morning, Dylan. Okay, so let's get going. And if you, well, everybody knows the routine. So when you drop in, please say good morning to everybody. This class has gotten a good feel about it that everyone does that. So my continuing appreciation that everyone's got a good attitude. It's helped me a lot. Hopefully you found some help in the mutual support. So let's get past me being stupid on Tuesday. So there's a trick that that not dumb programmers know what to do. Comment things out. And I was sort of trying to target my commenting out of things. So let me just show you where I'm at. What we did on Tuesday was we implemented the compute minimum macro. That's a fair amount of code, but we implemented that. We did not implement compute max yet. We did not implement compute average. Good morning, Jack. We incremented decrement mode, but we had that macro from the last lab, so I rewrote it, but we'd already seen that one before. We implemented increment mode, which is also coming back from the last lab before this one. And then we also did populate array, which we've now implemented a couple of different times, but we went through that exercise as well. So compute min was implemented. The only things left for today are compute max and compute average and getting this thing working. The other thing I'll remind us is that when we did populate array, we just kind of scrambled the data up a little bit. And the reason we did that is because we want to at least make the minimum and maximum algorithms get a little bit of exercise. So just stirred up the data a little bit, but we also know what to anticipate, right? The minimum should be 1, the maximum should be 10. And then the average, because we're doing it as integers and not floating point, will be 5 when we get there. So that's we scrambled them to make the algorithms work, but we also kept the numbers contained into a small range so that we could easily compute what the results should be. Okay. And then it was compiling, but it just wasn't working. So we need to do this first. Comment out all 3 of these things. Let's start with that, and let's just get the circuit running where let me see if I put the mode back. I did. So we want to be in mode 0. So double check yourself that you have mode 0 there. And then double check that you have commented out the compute, all 3 compute macro calls. And then I'm going to go fire up go through the compile process and just get the board running. Should work, because after we finished class on Tuesday, I went back and realized, oh, I should have just commented all of it out, and that got me working again. So recipe time. Let me bring up the browser so you can see it. You've seen this before, but anyway, I'm just going to go to the lab, grab the bits of the recipe, and do all that stuff. So the compile step, and that's all good. The elf step, that seems all good. The bin step, and the burn. Should get a jolly good. Okay. So let me show you what I got. So this is what we have now. It's in mode 0, which means it's just cycling through the array. That's awfully bright. So anyway, I will tilt it and reset, and it starts at 5, and then the numbers are kind of scrambled. So there's 5. So that's what we wanted. And if we switch modes right now, we've disabled their capabilities, but the mode indicator light changes, so now it's in mode 1 and not cycling. I'll click it again, a different color. Mode 2, but we don't have that enabled yet, and then mode 3. And again, we haven't enabled the code that goes with that. So 3, we're on 3, so we go down to 2, go down to 1, go down to 0, and it starts cycling again. So now we want to comment something back in. Okay, so I'm going to turn off the browser. So we have implemented, so that's what I didn't do on Tuesday. I just didn't comment the non-working things out to start. Maybe it's fatigue. Probably I'm not alone, and sometimes you're just not operating at your maximum. Okay, so we implemented compute min. So let's try it. And what that should allow us to do is toggle, let's see what mode that is. Okay, so that is mode 1. So we're going to go through the whole compile, elf, bin, burn process, save that. And then we should have mode 1 enabled, and mode 1 should show the value 1 when we run it. So let me know in chat if I'm going too fast, if you need me to hit pause while you get caught up. So we commented compute min in, and that should make mode 1 start to work. So I'm going to go back through the recipe. I'll hide my camera. So compile, elf, bin, burn, jolly good. So now I'm going to put my camera back where you can see it. Okay, so I'm going to reset, and it begins to cycle, so that's good. Now when I click the button and go out to mode 1, it should show me the minimum value, which should be 1. And there it is. So there's the minimum value in mode 1. If I go up to mode 2, we're not doing that calculation yet. If I go up to mode 3, we're not doing that calculation yet, but the mode indicator light changes. So mode 2, mode 1, aha, there's the minimum value. And then mode 0 is cycle all the values. So anyway, there's a takeaway. Even if that's the only takeaway the whole semester, sometimes just comment some things out, like the stuff that you haven't implemented. Works like magic. Okay, so hopefully we're good to, hopefully everyone's, some of you already had it cooperating, probably because you realized you needed to comment some things out. Whatever. Not me. Anyway, let's go do compute max, which is going to be very similar, of course, to compute min. It's a long one, so I'll talk through it and try to not go too fast. But it's very, very similar to compute min. So we're going to use the same algorithm. I'll go grab the algorithm and remind you about the algorithm as we'd write it. In a high-level language in pseudocode. So we're going to do the same thing that we did, although we're going to say, let's assume that the maximum is the first element of the array, and then we'll loop through the remaining elements, start at index 1, until we get to the end of the array. And if we find anybody in there who's bigger than the current max, then that one is the current max. So same algorithm. No doubt you've seen this algorithm before for searching a piece of target data in a data structure. Arrays, assume the first is your target, and then look through the rest and prove yourself wrong. Okay, pardon me. Compute, what are we on? Compute max, right? Yeah, compute max. Okay, so let's, hopefully let me just take a peek. I'm gonna try to do it in the same way, but it's a new day, so yeah. Okay, so let's get our array variable address, array var. So remember, array var is the parameter. Just checking chat. And then the backslash is in our assembler, how you access these parameters. And then I put underscore var when I'm referring to something in memory. And because it's in memory, we have to first start with its address. But then we can and if you want to, I don't think I did this in the earlier one. I'm going to try to not scroll too much. I didn't. I didn't do this in the compute min, but you can do 0 offset if you want to remind yourself. But of course, offsetting by 0 is offsetting by none. So that's optional, and I didn't do it in the compute min, but we could do it in the compute max just to prove that it works. Okay, so now we do the for I equals 1 piece. Check and chat. For I equals 1, so let's get the I equals 1. So we have a macro that does this work for us. So we will send it the offset variable, and again I have to use the backslash to refer to one of these parameters. So I'm going to call a macro, I'm going to pass along the offset variable, and I want to set it to 1. So the offset variable is going to be our I, basically. So this is I equals 1. We do the for max loop. So here's our loop, and we don't reset the offset variable inside the loop because it would get reset every pass and the offset variable thus wouldn't advance. Okay, so now we do, well, I'll just, same algorithm, right? So we need to get the value at this offset, at offset 1, and we're going to use sort of the fancy way of doing it. So first thing we need to do is get that offset variable. Now that it's been reset, we need to get it into a register. Then we will get the value of it. I'm being careful here, by the way. I don't want to touch R0 or R1 without being careful. R0 is the array, and R1 is my maximum value. So I'm being careful not to overwrite those. So I'm going to use R2 to get the offset variable here, and then I need to get the value of the offset variable so that I can use it, right? So now that I have R3, it's usable offset variable. So now what we do is we go load. I'll use R4 for this. So into R4, go to the array, that index, and scaled by logical shift left multiplies it by 4. Same algorithm we did for compute min. So what I've done here, this is the array base. This is the index, which is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then what the LSL2 does is it scales the index by 4 bytes. So instead of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's going to be 0, 4, 8, 12, 16, and so on all the way up to 36, which is the index 9 scaled or multiplied by 4. So all that really does is give me the next element of the array. and load that value into R4. That's all it did. I may be doing this in a different order than I did before. I don't remember. No, it's fine. Okay, so now we do the comparison. So now we're going to compare that R4, which is the next value in the array, with R1. R4 is greater than R1, which is the current maximum. Then we want to overwrite R1 with this R4, right? So if R4 is higher than R1, then we're going to move into R1 that value R4. So if R4 is greater than 1, then R1 max equals R4. Now I'm going kind of slow just because I don't want the assembly makes it really difficult to read. Hopefully what I've done is making sense to people. So that's that part of the logic. Now we need to advance the index. We need to move the I, and we have a macro for that. So I'm going to pass the offset variable to this increment and tell it to increment it by 1. So increment offset will actually increment it by any value that you specify. You can look at the macro if you want. It just adds that value. So this is the I++ step. All right, so now what we need to do is kind of redo the whole. So now what we need to do is we need to get, let's see, I need to be careful of R0 and R1, but I can reuse R2. So the question may come to your mind, like, why am I reloading the offset variable? And the reason why I'm redoing that is because I had it incremented in memory. So this macro actually alters the offset variable in memory, which means that I have to go redo the process of getting its address and then getting its current value, so that I pick up the update that's happened to it in memory. Now I also need, I'm just going to lump these up, I also need, I'm going to use R4 here, being careful with R0 and R1, I need the length of the array, and I need its value. R4. Okay, so I have R3 is I, and R5 is the array length. And the reason I need those is because I need to know if I is still less than the array length. So the way I'm going to do it, is this how I did it before? I did, yeah. So now I'm going to compare the I with the array length. If I is equal to the length of the array, then I got to stop. But as long as it's not equal to, then I can go back up into the loop. Be careful here, max loop, max loop. So as long as the I has not reached the length of the array, then it's safe to continue the loop. So this is my for loop. For I equals 1, I less than the array length, I plus plus. If the array at I is greater than max, then max equals the array at I. That's that whole thing, just like we did with min. Okay, so down here, we get to this spot once this branch doesn't happen. So this is after the loop ends, set, we have a set max var equal to R1, which is the max from the array. So I know this is after the loop because I won't get here unless this branch does not happen. So once this branch doesn't happen, then I know the loop's over. So kind of have to do the same thing. I need to be careful of R1 because that's my maximum still. So I'm going to load, I'll use R2 again. I need to get the address of that variable. That's the parameter, max var. You get the address of it, and then I can simply store R1 right back into that spot, and then the macro is done. I didn't need to get the current value of max var because I don't care what the current value is. I just want to overwrite that memory location. Last step, of course, is the pushes and the pops bit. So I used everything from R0 through R5. So I need to push all of R0 through R5. And then at the end, of course, pop all of R0 through R5. So that's a lot of code. And the purpose of having this experience, I guess, in the computer science world is so that you have some sense of what processors actually do when you write a for loop or when you write one of these algorithms. What does it actually look like in terms of the processor executing instructions? So it looks something like this. It also sort of, I think, makes you appreciate how nice high-level languages are, because I could have written this thing in 3 or 4 lines of code in C++, but in assembly, of course, it's 30 lines of code or so. Okay, so now we go back to main. This is the part where I need to be smart today. So back to main, comment in compute max, because that's now been implemented and I want to engage that functionality. Leaving compute average commented out, we haven't done it yet. So I'm going to scroll down and I'm going to notice that mode 0 is all the values, mode 1 is min, so mode 2 in theory should work to show the max, which I know is 10. So when I go through the compile process here, I should get mode 2 working and showing 10. Let me hide my camera and go through the compile steps again. Clear the screen. Compile. Elf. Bin. Flash. Jolly good. So I'm going to reset my board. Should be in mode 0 and it'll start cycling. And then I'm going to click the button, and when it catches up to me, it'll switch to mode 1, which is showing the minimum value. So there it is. The mode indicator changed. Ooh, that's bright. And then that's the minimum value. So when I go to mode 2, I should see the maximum value. Better be 10. So that's 8 and 2 is 10. Mode indicator changed and it's showing 10. That is the maximum value, so that algorithm seemed to work. If I go up to mode 3, that functionality is not yet engaged. Mode 2, there's the 10, which is max. Mode 1, there's the 1, which is min. Mode 0, cycle all of them. Feeling pretty good. All right. I'm going to give you a minute or so breather, so you can sort of let me know if you're having an issue and let the group help you fix it. So in main, just note that we have now put back compute max and compute min. And then in the macros file, it's a long algorithm, but this is the compute max code. Which, because I put the extra notes in there, it's hard to show the whole thing. But I also wanted to show the algorithm I'm using. Okay, so this is compute max. If I take these notes out, let's see if you can see the whole thing. Yeah, you can. So there's compute max. I just took the extra notes out. And if you're watching the video later, of course, you can pause on this. And then I'm also going to do that for compute min for those of you who are watching the video later. So here's compute minimum that we did the other day. I'm going to take the notes out. So there's compute min. All of that's compute min. Okay. Compute max. Leaving it there for a few seconds. For video watchers, you can pause. So all of that, you can see the macro top and bottom. Okay, compute average. Let's do this in 2 steps, I propose, so that we can test each of the steps. So the first step will be to compute the sum of values. So we're going to use a loop basically and sum up all the values, and then we're going to display that as the average for part 1, right? So it's not actually going to be the average, it's going to be the sum, but we're going to put the sum in this memory location just to test that part of the algorithm, and then we'll go do the division part that will get the average. These are integers, by the way, so you're not going to get like a 5.2 or a 7.5. It's going to be clipped to an integer. All right, so this is going to look very familiar because it's a similar loop, except for we're going to start at 0 and then just make a sum. So let's load into R0 the address of the array var, and I use the backslash because that's a macro parameter. So R0 is the address. I'm also going to do a reset on the offset variable, reset it to 0. So that's, well, that's it. That's for I equals 0. Here's the loop part. So there's the loop. And then we just have to pick a register. We're just going to pick a register. And I'll just use, I don't know, we'll just use R1, I guess, for the maximum value. But in the loop, what we're going to have to do is we're going to have to load, actually we'll use something else, because into R1 I'm going to put the address of the offset variable, and then I'm going to get its current value into R2. The reason why we're doing this is because the offset variable, is going to change over time, so every time we come back through the loop, we need to grab its current value. Okay, so R0 is the array, R2 is I, and then I guess I'm going to use R3. Let's use R3. So now that I know that, I'm going to say move R3 0. So I'm going to use R3 now that I sort of figured out my other parts for my sum. And I'm going to make sure that it's 0 to start. So R3 is going to be my summing variable, which I'm going to start at 0. Then I get the array and the I. Now I can, I should have used a different, it's fine, I just have to be careful. So be careful of R0, be careful of R2, be careful of R3. So what do we need? We need to load the next value from the array. So I'm being careful of R3 because I'm using it for something, so I'll use R4. The next value from the array is go to the array, go to the index or offset, and scale it by 4 bytes, which is what logical shift left 2 does, is actually multiply it by 4. If you think about that in binary, by the way, so logical shift left 2 goes from 2 to the 0 to 2 squared. So 2 to the 0 to 2 to the first to 2 squared, which has the same effect of multiplying something by 4. So R4 is the next value in the array from this index scaled by 4 bytes. Here's the array. Then we're just going to take that and we're going to add it. So this is R3 sum plus equals R4, which is the next value from the array. Then we need to increment the offset variable one at a time. What else do we need? So we need, being careful of R3, remember, R0 and R3 are very, very important. So I need to grab, can I use R4? I can use R4 if I want, but let's use R5 just to be on the safe side. You've seen this before. We need to compare the offset with the array length to know when to keep the loop executing. So we've done this in the compute min and compute max. I'm going to load into R6. We're getting up there now, that value. Ooh, we're using a lot, aren't we? But I can use R1 and R2 again, so that's okay. Okay, so let me just explain to you what I've done here. R3 is my sum, which I start at 0. R0 is going to be where my array lives. Then my offset variable is my I, so I do I equals 0 for indexing purposes. Then I go grab the value of I and put it into R2. And then this is the array at I, so R4 equals the array at I, and then I take R4 and I add it to my growing sum. So whatever R3 is now accumulated with the addition of R4. Then I do I++. Then I have to, unfortunately, because we're in assembly, I have to go and re-grab the value of I into a register, which is R2. So R2 is now the value of the updated I. Then I get the array length value, R6, which I know to be 10. There's 10 elements, but that's what it is. Then I say, is R2 equal to R6? If I is the same as the array length, then my loop is over. But as long as it's not reached R6, then it's safe to keep going. So here's the for loop. The effect of doing all that work means that when I get out of the for loop, so this is after the for loop, R3 has the sum. Of all the array values. So we're going to do this in 2 steps. So the first step is we're not going to do the division part just yet, but I am going to leave a note for myself. We're going to need to divide the sum by the array length, which probably goes without saying, but we're not going to do that yet. I'm just leaving a note that I need to do that. Short term, what I'm going to do is I need to get the address, so I need to be careful of R3, that's my sum. Get the address, though, of the average variable. And then I'm going to store the sum into it. Hopefully everyone gets this. Until I've done this division step, R3 is just the sum. But I'm going to see if the sum works. So I'm actually going to run the circuit, and when I get to mode 4, it should be the sum right now and not the average. Now I need to check all the registers that I use, which I think is everything from R0 through R6. So push everything from R0 to R6 and pop everything from R0 to R6, R0 to R6. Remember, right now, we only have the sum. We don't have the average. We're going to have to put a division instruction in here. But let's see if the sum shows 55, which is, I think, what it's supposed to be. So what you're looking at on the screen is the entire compute average macro right now, less one instruction, which is critical because that's how we get the average. All right, so let me hide my camera. Let me go back through all the steps. So compile, elf, bin, burn, jolly good. So I'll show you my camera again. I'm going to hit the reset button. All right, cycling. That's mode 0. I'm going to hit, and it'll catch up to me eventually. It'll go into mode 1. There's mode 1, and that's the minimum value. Mode 2, that's the maximum value. Mode 3 isn't showing anything, which I'm sad about. Which means that I probably made a mistake. Move 0 to R3. There's the add, so accumulate. Values, I increment the offset, so that's good. Oh, yes. Thank you, Jack. So this is the, yes. So you have to, commenting out is great, but it doesn't help if you don't comment it back in later. Good catch, thank you. Hey, commenting works. So there. I've demonstrated in a whole bunch of different ways how commenting and uncommenting work, and if you're paying attention. So thank you, Jack, for paying attention, because I wasn't. I forgot to comment that in. So I have to go back through the entire build process. Compile, elf, bin, burn, and now let's hope that there's some magic going on here. Reset. There's the cycle. And there's the min. There's the max. Aha! What a miracle. So let's do the math. I'm going to do the binary math. So that's 1 plus 2 is 3. Plus 4 is 7. 8, 16. 7 and 16 is 23. 23 and 32 is 55. Aha! So that's the sum in mode 3. So now we got to go hit it with the div. Mode 2 is max, mode 1 is min, mode 0 is cycle. All right, we're just about there. Wait. Comment and uncomment. All right, it's uncommented. So all we have to do is the one missing instruction in the macro, which is divide the sum by the array length. So this is unsigned division, so we're going to have to use udiv. So we have the sum, that's R3. We're also going to need let's worry about the R3 is the one we need to make sure we don't mess with, but we need to get the address of the array length. That's our denominator, so we're going to divide by that, so we need to get the value of it. So, but we know that to be 10. So now we have the denominator, the 10 in R1. And then we're going to udiv. And we're going to have to, I'm going to switch the registers here in a second. Unsigned division. The way this thing works is where you want the result to go. So I'm going to put it in R4. Is the result of dividing R3, which is the sum, by R1, which is the length of the array. Hopefully I got those in the right order. So there's the division piece. So at this point, R4 is the average. So now if you're watching on video, be careful here because people are likely to make a mistake. I'm going to take that extra line out. R4 is the average now. So when I do this store step, I want to store the average, not the sum, because that's what we ultimately want to see is the average. It should be 55 divided by 5 as integers, which is 5. So be careful here that you get, especially this last one, we're storing R4 because R4 is the result of dividing the sum by the length of the array. If we had put in a mode 5, I guess we could have put like the remainder part, but we're not going to do that. So let me show all of, does it fit? It does. So there, on the screen is compute average. If you're watching on video later, the whole thing is there. Everything's commented in main. So we should be good for the last thing, which is to go rebuild it and then run it on the board. Compile, elf, bin, flash, jolly good, everything's commented in. Turn the camera back on, I'm going to reset the board. So there's mode 1, mode 0 rather. Mode 1, we'll switch to it in a second. So mode 1, which is the minimum value 1. Mode 2, the maximum value 10, which is 2 squared plus 2 cubed, that's 10. And then average, thank goodness it's 5. So 2 to the 0 plus 2 squared, that's 4 plus 1 is 5. So there's the average value showing in mode 3, the average of the array elements. Average, max, min, cycle all of them. I'm not going to burden us with it, but if you were so inclined, you could swap out a few of the values. We wrote the whole thing as unsigned integers, so if you play around with the integer values, just use positive ones. Is my only warning to you about it, is use positive values because we did everything unsigned. Just because there's no need to do signed. It wouldn't have changed any of the sort of seeing the algorithms. So I'm pretty happy. Min, max, average, max, min, cycle. So there, that's the big show of the whole semester right there. Not easy. That's a lot of assembly coding work to do. That's all that I have for today. I'm going to put a note up here before I bring the screen back, just so you've all seen it, and if anyone's watching video. So Tuesday is May the 26th. Where we'll do a final review. And that's it. Hopefully I didn't go too fast. I'm happy to sit around and answer questions. I hope that you're getting good results, that you get the satisfaction of seeing this very complicated piece of assembly coding work. And then I can also show chunks of code again if you want to see them. But otherwise, I thank you all. Your class did. Thank goodness. All right, that's good news, Brooksy. And it feels good. Uh, your class did a great job. Just about everybody stuck it out through to the end. This is not the ideal circumstance. Not all of us like this online environment. I personally don't. But so I thank you for your good attitude, and the good mornings really helped. And I think most of us can walk away feeling like we got some good results out of it. Hopefully that's true for you. Anyway, just please note, we do have one more meeting. We'll do a final review. There is um, an assignment that looks like one of the homework, so we'll fill out the final review together on Tuesday, and then we will be done. So if you're done, have a great weekend. If you're not done and need my help, I'll sit it out for a few minutes and wait for your questions. No kidding. I know. You complain about pointers and all that stuff in C++. Thank you, Vince. I appreciate it, man. Yeah, Brooksy. Yeah, I think if nothing else, you walk away from this kind of experience thinking C++ isn't that bad. Um, the pointers are nasty, but now you actually have a sense of what those look like under the hood also. Um, I don't know that C++ makes pointers any prettier, but it certainly makes a lot of the rest of it look nicer. Yeah, thanks, Jack. Me too. I always feel like I'm just sort of blind to what people are experiencing in this format, so it's I find it difficult and not ideal, but fortunately everyone sort of found the rhythm I think in this class, and we stuck it out and got the work done, so that's nice. Yep, see you in an hour. Thank you, Dice K. I appreciate it. See everyone. See you guys on Tuesday for our last meeting next week. Have a good weekend in between. Thanks, Dylan. Appreciate it.